We are starting with the third lecture on representation of data. The first subtopic that we are studying, that is mean and standard deviation. Now, what we have done in the first class, in the very first class, we studied the basic concept of mean and standard deviation. In the second class, we introduced the concept of coding, assume mean. What is coding? What is assume mean? Let's go back a bit. And then we will be doing miscellaneous problems on basic mean and standard deviation, as well as coding. This was the beginning of the second lecture. When we got started, we said that if I compare set 1 with set 2, if there is a constant addition of a number to all the values in the data, only the mean is changed by that data, standard deviation remains unchanged. This was the beginning of coding. Then I took 5 numbers, 101, 102, 103, 104, 105. If I use the original data, I calculate the mean, it comes out to be 103. If I want to make a substitution so that the numbers become small, I make a substitution, I make a coding, y is equals to x minus 100. That means from each value of x, subtract the mean, subtract 100, and the numbers become smaller, 1, 2, 3, 4, 5. Now when I calculate the mean, it comes out to be 3. That means for my convenience, for simplicity, for making life easier, what I have done is that I have subtracted 100. So the mean that I got, that is in terms of y bar, I should add back 100 and I'll get the original mean. Why? Because mean is affected by addition, subtraction. I subtracted 100 in the beginning for my simplicity, for ease of working. Once that working is done, I should add back the 100. But when we talk about standard deviation, whether we calculate it from the original big numbers or we calculate it from the small numbers which are obtained using coding, we observe that the standard deviation remains unchanged. Then frequency distribution with coding. We had numbers like these, we had data like these. We made a coding y is x minus 312. This you don't need to worry about, the examiner will give it. You work everything in terms of y, a column for y, y square, fy square. You calculate y bar, you calculate the variance or the standard deviation, whichever one they have asked for. The mean is increased by that value, whichever value was subtracted. In this case, that was 312. So add back 312. What will happen to the standard deviation? Standard deviation remains unchanged. Then we did 2 simple questions. One was based upon raw data. Other one was based upon frequency distribution. In these 2 examples, the examiner has already carried out the process of assume mean, the process of coding, and they have given you summarized data. Whatever is in the bracket, that expression, x minus 50 in this case is y. So you calculate y bar, you calculate standard deviation for variable y, standard deviation for variable x remains the same, mean for x bar, that is increased by 50. In this scenario, since there is an f attached, that means the data is in the form of frequency distribution. Those formulas would be valid. What is y in this case? X minus 100. You calculate y bar, you calculate standard deviation for variable y, x bar would be increased by 100, standard deviation for x would be the same as standard deviation for y. This is the basic concept that we are revising. Then we went to past paper questions. The first question was spot check, spot on, it was easy. Second one was about the length of time for the crossword puzzle, straightforward. In the third example, A was unknown. Now, what tool do you have? What resources are available? The resource, the equation, the substitution that's available. that links the two variables is y is equals to x minus a. In this case, that a is unknown. You can calculate y bar. You already have x bar, hence you find the value of a. And then the examiner is asking for standard deviation of x, which is in fact the standard deviation of y. Now, for example, for some reason, if someone is unable to do first part, it has no connection whatsoever with the second part. Because whether you obtain the value of a or you are unable to do so, or you obtain a wrong value of a, that doesn't affect your calculation for the second part. This was the third past paper question that we did. Now, I did something extra. What I did something extra was that if, based upon the information given, I want to calculate sigma x square. So sigma x square is standard deviation square plus the mean square multiplied by the number of observation. If it's talking about x square, the standard deviation should be for x. The x bar, of course, naturally it's for x, and the number is the same. So what I did in this scenario is that I calculated x bar. Maybe the examiner could ask for it. Maybe that could be the third part. Okay. So that was the modification in this question. I added an extra part. Then this is the same thing. So I can erase it. And then let's move on. This is the fourth question. Again, more or less of the same caliber. Standard deviation of x or standard deviation of y. You calculate y bar, you add 130, you get the value of x bar. And this second part, sigma x minus 130 square, you have to realize the fact, you have to comprehend the question, you have to understand that sigma x minus 130 square, it's not something foreign, it is not something alien. This is technically sigma y square, which would be obtained the same way as that extra part in this question. Okay, so now let's start with today's lecture. More and more problems on mean and standard deviation. So now we are starting with a slightly difficult question, slightly conceptual question. In order to make you understand that concept, let me take 5 numbers, the same favorite 5 numbers, 101, 102, 103, 104, 105. I added the values of x, that comes out to be 515. I now made a substitution, used the substitution, y is equals to x minus 100. So the 5 numbers, they all become very, very small, and they simply become 1, 2, 3, 4, 5. Now, what am I going to do? I'm going to calculate sigma x minus 100, which is 15. Now, this is the information that I have, correct? Now, for example, if I add a page, and if I say sigma x, I don't have the original data, that is missing. If I have sigma x is equals to 515, and I say number of sample is 5, and the coding I'm using is x minus 100. And the examiner is asking me, calculate sigma x minus 100 square. Can I calculate this? Yes, I can, without even knowing the original data. Because the trick is, there were 5 pieces of observation. Whatever was the original data, 100 was subtracted 5 times from that data. That means the original data could be A, B, C, D, E. And then we subtracted 100 from each one of them. And what I get is that F, G, H, I, J. The sum of these 5 is what they are looking for. I don't have the original one, so I cannot use the original data and then subtract 100. But I know that 500 should be subtracted. Therefore, sigma x minus 100 is basically sigma x minus Whatever value was subtracted originally, that multiplied by n. That means sigma x is 515, 100 is 100 in this scenario, and n is 5. Therefore, this comes out to be 15, which is exactly the same thing as the previous one. Now, this small knowledge, this basic knowledge will now be used in the second part, in a new question. Let's read the question first. Asme noted that the test marks X of 16 people in a class. She found that sigma X is 824 and the standard deviation of X was 6.5. Calculate sigma X minus 50, sigma X minus 50 square. Now let's first focus on sigma X minus 50. Link it with the previous question. What do we have? We had sigma X, number of sample was 5, amount subtracted was 100. That means 5 times 100 was to be subtracted. Now in this scenario, what we need to do is that we need to look at the question, and let me do it again instead of looking at the solution which is given. So now if I plug it in over here, the first thing first, part 1, sigma X minus 50 is technically sigma X minus, we are dealing with 16 people and 50 is being subtracted. So therefore this is 16 times 50. So therefore this is 824 minus 800. That comes out to be 24. That is a simple calculation for this part. Now, basically, the substitution that we are using is y is equals to x minus 50. Agreed? So sigma x minus 50 is sigma y, and sigma x minus 50 square is sigma y square. I cannot calculate sigma x minus 50 whole square without the original data. Therefore, I need to use the same formula, sigma y square. I can either use a formula that you remember, or we all know how to do algebraic manipulation. So we can say standard deviation of y is sigma y square over n minus y bar square. And there is no need of an under root because I have put a square on the other side. They are saying standard deviation of x is 6.5. That is the same thing as standard deviation of y. So now look at the working. What is the working? 6.5 square is equals to sigma y square over n. N is 16 minus y bar. What is y bar? Y bar, can I calculate it? Yes, I can calculate it. Y bar is sigma y over n, which is 24 over 16, which comes out to be 1.5. So this is 1.5 square. Therefore, when I make sigma y square the subject, that is 6.5 square plus 1.5 square, bracket closed, multiplied with 16, and that answer is on the next page. That comes out to be 712. So this answer is 712. So sigma x minus 50 whole square for the data Asme calculated is sigma y square, which is 712. So now look at this working. Straightforward. Let's move on. Now, what is the next thing that they're asking? They are asking, and this time I'll do it using one method only, because people find the second method a bit tricky. So now let me do something extra. In fact, this is not extra, this is the useful extra. Now, what I know is that standard deviation of x is 6.5. And what else do I know? I know that x bar would be y bar plus 50, which will be 51.5. I know the number of sample to be 16. And can I calculate sigma x square? Yes, I can. Based upon the same working I just did for y. Standard deviation x square is equals to sigma x square over n minus x bar square. I can this time first make the subject. Sigma x square is SD square x bar square bracket closed multiplied by n. Therefore, this is 6.5 square plus x bar square. X bar is how much? 51.5 square bracket closed multiplied by n, which is 16. Let's look at the value of sigma x square, which is 43112. Done. Now let's move to the third part. Now it's saying it says that one person did the test later and then her mark was 72. Calculate the new mean and standard deviation. Sigma x for 16 people was 824. Sigma x for 17 people would be 824 plus 72. That is one working that I need to do. So 824 plus 72, that is 896. Similarly, sigma x square for 16 people is 43112. Therefore, sigma x square for 17 people is 43112 plus 72 square. So therefore, 72 times 72 plus 43112, and this comes out to be 48296. Number was initially 16. Of course, we know the number now is 17. What else do I need? I need x bar for 17 people. So x bar for 17 people is sigma x for 17 people divided by number of 17 people. So therefore, this is 896 divided by 17. Let's see how it comes out to, how much it comes out to be. 896 divided by 17. That comes out to be 52.71. 52.71, correct to 4 significant figures. Now, the very last part, that is standard deviation. X bar is done for 17. Standard deviation for 17 people. Let me first write it for variance. That is sigma x square for 17 divided by number of 17 minus x bar for 17. X bar for 17 square. So therefore, sigma x square is 48296 divided by 17 minus 52.70 square. And then you use a calculator and then you get the answer. So that is the easiest method of doing the second part. Okay. Should I show you the difficult method? Let me remove this. This is the difficult one, okay? But we don't need to use it. You can later on watch, stop and pause the video and then see it if you want to. But as such, there is no need. This is erased and this is erased. Now let's move on. Another question. First, read the question. Dilip measured the speeds x kilometer per hour of 70 cars on the road, where the speed limit is 60 kilometers per hour. His results are summarized by such and such. Calculate the mean speed of these 70 cars. That is straightforward. Let's have a look. Let y is equals to x minus 50. X minus 60, sorry. Sigma y is 245. Y bar is 245 over 70. Therefore, the mean speed would be x is equals to y plus 60, x bar is equals to y bar plus 60. You add the two, and then you get the answer. Now it says, his friend Sachin used values of x to calculate the mean. Use values of x minus 50. That means his friend is also too much into stats. And instead of using the original data, he's doing a different kind of coding. Whichever coding Sachin or Dilip uses, there is one truth, that is the x bar, the original mean will not change. The intermediate coding x bar or y bar or w bar or anything bar could be different based upon the coding, but the final x bar should be the same. And this is the knowledge that we use. Let w is equals to x minus 50. So sigma w is this thing. I think I'm doing the working for the next part. I think this is the part that I need to use. Okay. Let me just go back a bit. And let me do it fresh. Okay. Now, first of all, you would say, let y is equals to x minus 50. Y we have already used. Let's use w. Therefore, this thing is sigma w. Therefore, if I want to calculate, first of all, I can say w is x minus 50. W bar is equals to x bar minus 50. Do we have w bar? No. Do we have x bar? Yes. 63.5 minus 50, that comes out to be 13.5. That is the first part. That is the most obvious thing. That is what's in my hand, what I can calculate. Now I can say w bar is sigma w over n. Therefore, w bar is 13.5. Sigma w is what we are looking for, what they are asking. N is how much? N is 70. So therefore, 70 multiplied by 13.5, that comes out to be 945. So sigma w is 945. And sigma w is, in fact, sigma x minus 50. You can already state it at the beginning, that sigma x minus 50 is sigma w. That is the second part. Now, let's move on. Let's move to the last part. What are they asking in the very last part? They are asking the standard deviation of the speeds is 10.6. That means standard deviation for variable x, standard deviation for variable y, standard deviation for variable w. That's all equal. So therefore, this time what they are asking is sigma w square, the same traditional working. Standard deviation w square is sigma w square over n minus w bar square. Am I right? Sigma w square should be made the subject. That is standard deviation square of w, w bar square, bracket closed, multiply it with n. Therefore, this is 10.6 square. W bar square is 13.5 square, bracket closed, multiplied by n. What is n? 70. And then you get this answer. So if you do step by step, if you relate it with the original basic questions, then things become easy. So first we did the question for Asme, and then the second question was for Dilip. Okay, I need to erase it, erase it, erase it. Now let's move on. Question number 12. A sample of 36 data values, X is given. Find the mean and standard deviation of these values. Again, first part is pretty straightforward. Let y is equals to x minus 45. Sigma y is minus 148. Sigma y square is 3089. First of all, what should I find? Always it's the mean. Y bar, sigma y over n. Sigma y is minus 148 and n is 36. So therefore, 148 divided by 36, that comes out to be negative 4.111. Therefore, x bar should be y bar plus 140 plus 45. So when I add 45 to it, this comes out to be 40.88 or 40.89. Okay, what else? Sigma x minus 45 whole square is this, and they are looking for standard deviation. So standard deviation square, this is sigma y square over n minus y bar square, under root I'm not putting in, 3089 divided by 36 minus, either you use the fraction or you can use the, I think better to use the fraction, 148 over 36 square, and then let the calculator do the final calculation. Therefore, SD is this thing. Now, one extra value of 29 was added to the sample. So when one extra value of 29 was added, what is happening? Sigma, work in the original thing. Oh, if I want to work in the original thing, I don't have sigma x, correct? So therefore, I should calculate sigma x. We know that x bar is 40.89. We know that n is 36. Therefore, x bar is sigma x over n. Therefore, sigma x is n times x bar. So that is 36 into 40.89. So 40.89 multiplied by 36, that comes out to be 1472.04. Use this value as it is. Now, what else do I need? Do I have x bar, sigma x bar? No, I can also calculate that. Standard deviation of x is the same thing as standard deviation of y. Standard deviation, I did not calculate, but I can do the calculation. I can show you the steps. So first of all, let me do the calculation. 3089 divided by 36. This comes out to be 85.81 minus y bar was minus 4.111 square. So 8581, keep it on the side. 4.111 multiplied by 4.111. I don't have a scientific calculator, that's why I'm using the phone. So therefore, this comes out to be 85.81 minus 16.90. So therefore, this is the square still. So 85.81 minus 16.90, that comes out to be 68.91. So 68.91 is variance, and SD would be square root of 68.91. So I'll just use 68.91. Variance, therefore that is 68.91. And instead of variance, let me use the word standard deviation, square root of 68.91. Therefore, SDX whole square, that is sigma x square over n. N is 36, I'll use it later, minus x bar square. So therefore, 68.91 after the squaring, sigma x square, n is 36 minus x bar. What is x bar? X bar is 40.89. Therefore, if I make sigma x square the subject, that is 68.91 square. Sorry, 68.91 was already squared plus 40.89 square, bracket close, multiplied by 36, and you get a value. Then the working would be as simple as this particular working. This one, just like a Smith. For 17, you add that particular score, which was 29. For sigma x square, you square 29 and then add it up. You already have the new mean. You can calculate the new mean, and then you can calculate the mean and standard deviation. So therefore, they're only asking for the standard deviation. Of course, mean is part of the game. You have to calculate the mean in order to calculate standard deviation. So this one. Done. I'll just write down these steps. So now sigma x is given. That is 1472.04. Therefore, sigma x new would be 1472.04 plus, what is the score? 29. X bar new would be 1472.04 plus 29 divided by 37. The new score is 37. And a sigma x square old was something. I don't know what was that. Sigma x square new would be that value plus 29 square. And then the new x bar is given. So therefore, standard deviation for new, that is sigma x square new divided by number of new, which is 37, minus x bar new square, and then you get the answer. Don't forget to take the square root. Okay, let's move on. This question we'll just read. I think it is more or less of the same caliber. The values of x in a particular set of data are summarized. Let me first write the substitution. That's the first thing you should do. Let y is equals to x minus 25. Therefore, this is sigma y. This is sigma y square. Mean is this much. Find the standard deviation of x. Why have they given us the mean? The original mean. They don't want us to calculate y bar. What is the reason for that? Let's see. Y bar is sigma y over n. Therefore, 133 divided by n. What is missing? The values x in a particular set of data are given. N is unknown. They're not asking us for n, but we need to know what is n. Y is equals to x minus 25. Y bar is x bar minus 25. Y bar is 133 over n. X bar is 28.325 minus 25. So this question was not a simple one. So therefore, 3.325 multiplied by n is 133. So basically 133 divided by 3.325. This comes out to be a nice number. N comes out to be 40. So that is what you have to calculate without, you cannot think about moving further without even knowing the value of n. Then what does it say? They are asking us for standard deviation of x. Standard deviation of x is the same thing as standard deviation of y, that is sigma y square over n minus y bar square. So we know that y bar is first of all, let me write sigma y square, 3762, n is 40 minus 3.325 square. How did I obtain 3.325? The difference between these two is y bar. And this is SD y square. Standard deviation of x is the same thing as standard deviation of y. And you just use a calculator, square root, and then you get the answer. Last part is again the simple one, sigma x square. Okay, if I want to calculate sigma x square, let's see what do I have. So put it in the corner. First of all, I have x bar, which is 28.325. I have n, which is 40. Can I calculate sigma x? Sigma x is 40 into 28.325. So let's use a calculator. 40 multiplied by 28.325. This comes out to be 1133. And standard deviation, I need to get the value. Standard deviation is 3762 divided by 40. That comes out to be 94.05. That is exact. No rounding off. And then 3.325 square. 3.325 into 3.325. That comes out to be 11.055. 11.055. That's enough. Minus 94.05. That comes out to be 82.99. So that is 82.99. Therefore, SD for variable y, for variable x doesn't make a difference, a square root of 82.99. So therefore, when the working starts, SD for x square is sigma x square over n minus x bar square. The same calculation over and over again. Sigma x square is SD x square plus x bar square, bracket closed, multiplied by n. That is 82.99. So that's the square root of 82.99 square. And this is x bar, which is 28.325 square, bracket closed. Don't forget to multiply by 40. That will give us sigma x square. Okay, so a lot of questions that we have done of different kind of difficulty level, different kinds of questions being asked. Okay, let's move on. The amount of money, X dollars, that 24 people had in their pocket was summarized by such and such. Find sigma X and sigma X square. Pretty straightforward now. A summary of the speeds X kilometers per hour of 22 cars passing a certain point gave the following information: sigma this, find the variance of speed and find the value of sigma X square. These questions that I'm skipping, these are your homework. Swati measured the length of 18 stick in 6 and found that sigma X square is 967. Given that the mean length is this much, find the value of sigma X minus 5 and sigma X minus 5 whole square. Now, this is one nice question. First thing first, what is the first thing that we do in a question related to coding? We first write what is y. Let y equals to x minus 5. So basically, the question they are asking calculate sigma y. This is unknown, and they are asking us sigma y square. These two things they're asking us. Now, when we talk about sigma x minus 5, this question is like what we started after the revision, the ASME question. 50 was subtracted how many times? 16 times. It has something to do with that. Maybe everything to do with that. Sigma x, first of all, you need to calculate it. The mean length, the original x bar, is 58 over 9. Number of sample is 18. Can I calculate sigma x? Yes. That is n into x bar. That is 18 into 58 over 9. So that comes out to be 116. Simple calculation. Now, sigma x is 116. 5 was subtracted 18 times. So 5 into 18, that is 90. Therefore, sigma x minus 5 is technically 116 minus 5 into 18. Just showing you the step. 5 was subtracted 18 times. In that question, we were subtracting 50 16 times. So 116 minus 90, that comes out to be 26. So first thing is found, therefore sigma y is found, that is 26. Now what? Can I find standard deviation for x? Yes, I can. So let me do the working. I have x bar 58 over 9. I have number as 18 What else do I have? I have sigma x square. That is 967. And now I'll calculate standard deviation for x, or variance of x. So SDX square, that is 967 over 18 minus 58 over 9 whole square. Let's leave it as it is. No need to calculate at this moment. If I am talking about y, do I have y bar? Can I calculate y bar? Yes, I can. That is 26. Sigma x minus 5 is 26. So for calculation of y bar, I have sigma y, which is 26. I have number, which is 18. So y bar is 26 over 18. Done. What else do I have? Do I have sigma y square? I think we just calculated it. Sigma y square, that's what we are going to calculate. That is unknown. Can I make a formula for standard deviation of y? Yes, standard deviation or variance of y, that is sigma y square over 18 minus 26 over 18 square. Don't we know the fact that standard deviation of x is the same thing as standard deviation of y? Yes. So therefore, these two are equal. Therefore, this box, just focus on this box. So the working is all done. Sigma y square over 18 minus 26 over 18 whole square is equals to 967 over 18 minus 58 over 9 whole square. You can easily make sigma y square the subject and use the calculator once for all, so that you don't lose marks on accuracy. Sigma y square over 18 is equals to 967 over 18 minus 58 over 9 square plus 26 over 18 square. And then after you have evaluated it, you can make sigma y square subject of the equation, and then you get the answer. So I hope you have liked, you are still liking this chapter, a very conceptual chapter of S1. And believe me, after you have done this S1 course, anything to do with starts in life, that would be a piece of cake for you. S1 is the first barrier, the major barrier that you come across. Everything else would be based upon the principles that you have studied over here. Now, this question, question 19, this is like that A question at the very beginning. And then this is something like Asme. This is something like what we have just did. This is a nice one. This one. Let's have a look. The last question before I sign off for the other class. 12 values of x are shown in the table. Find the mean and standard deviation of x minus 1760. Hence, the mean and standard deviation of x. Now, this is the first time that the examiner is asking us to do the coding. Instead of the summarized data, what you have to do is that from each value, subtract 1760. When you subtract 1760, the numbers become very, very small. You calculate sigma y. You calculate y bar. You square each value. You calculate sigma y square. Standard deviation of y and standard deviation of x is the same, whereas x bar would be whatever is your value of y bar and add to it 1760. So go through this exercise thoroughly, and then you have to start working after 3 classes of mean and standard deviation.